Current against voltage characteristics. To find how the current varies for a changing potential difference for different electrical components, we could use a circuit like this, where we have the component under test, which I've given this symbol, in series with a variable resistor. We also have an ammeter in series to measure the current, and a voltmeter across the component. These could of course be replaced by sensors connected up to a data logger. So this circuit uses a variable resistor, and it would allow a potential difference from a minimum value up to a maximum of that supplied by, in this case, the cell. We could also use this circuit, which involves a potential divider, this being the potential divider. This allows us to have potential differences from 0 to the maximum of the supply potential difference. So this clearly has advantages in giving a bigger range. If we plotted a graph of the results, we'd get a line something like this for an ohmic conductor. That could be a wire or a resistor as long as they were at constant temperature. They obey Ohm's law, which is that the current is directly proportional to the potential difference. This would be the symbol of a fixed resistor, which, as long as the temperature were constant, would more or less obey Ohm's law. We would obtain data something like this from a filament lamp. This is because the resistance of the filament increases with temperature. This would be the symbol of a filament lamp. For both these components, it doesn't matter which way round it is placed in the circuit. For these graphs, we have here potential difference in the positive direction and in the negative direction, and current in the positive direction and in the negative direction. And as the negative side is simply the opposite of the positive side, it shows us that the direction does not matter. However, this is very different. We have a very different display of characteristics in the negative side to that in the positive side. This is the data we would obtain on a semiconductor diode. In the positive direction, when we get to around about 0.6 volts, the current rapidly rises. It suddenly goes from having a very high resistance to a very low resistance. However, in the negative direction, however much the potential difference is, we have virtually no current, showing it has a very high resistance in the negative direction. So just to repeat, it has low resistance in the forward direction or forward bias when it is above about 0.6 volts, and it has very high resistance in the reverse direction or reverse bias. This is the circuit symbol for a semiconductor diode, and as you'd expect, this, effectively like an arrowhead, shows the direction in which current is able to flow, with current not being able to flow in this direction.